number systems. The topic is factorials, right? So here we have, first of all, we need to know what factorials mean. So all of you very well know that factorial is nothing but the product of the number till 1. That is, if you're asked to find n factorial, what do? 1 into 2 into etc. till n, or n into n minus 1 etc. till 1 is what is n factorial, right? There is a very typical question that we get from this particular topic, which is what we are going to discuss in this video. The question is like this: find the largest power of 2 contained in 10 factorial, right? Largest power of 2 contained in 10 factorial. So what are the given things here? We have been given this number. What kind of a number is this? This is a prime number. We'll also be looking at examples with composite numbers. First, let's start with a small, very simple problem, that is power of 2 contained in 10 factorial, right? So how will we do this, or what does, first of all, what does this question mean? The question means how many 2's are there in 10 factorial. Now, what is 10 factorial? 10 factorial is 10 into 9 into 8 into 7, etc. 1, right? But here we have to find the 2's in this 10 into 9 into 8 into 7, etc. 1. How many 2's appear here? This is what we have to find out. So we have, if we list it out, for example, 1 into 2, there we find a 2. Then if we go to 4, we find two 2's are there. Then if we go to 6, again we get 1 2, right? Then 8, 3 2's are there, okay? And in 10 you have 1 2. So totally you'll have 8. If you list it out, you can try it out now. That is, if you list out all the 2's here, you'll get 8. And that is what they have asked us. How many 2's are there in 10 factorial? You have to get all the 2's that are there. Now, listing out is not always easy. Right now, we are dealing with 10 factorial. It's fine. But what if it's a bigger number? What do we do? Actually, what are we doing here? Let us understand it in a better way. So, our objective is to find all the 2's in 10 factorial. Where can we find the 2's? We can find one set of 2's we can find in multiples of 2. Okay. So, how do we find multiples of 2? Here, the multiples of 2 are 2, 4, 6, 8 and 10. So we have 5 multiples of 2. Suppose we don't need to count. Then what do we do? What can we do? We can just divide it by 2 and we will get the multiples of 2. So we have 5 multiples of 2 here. Then next, where we haven't covered all the 2's. Okay, for example, if we take 4. 4 is a multiple of 2. I have just counted 1 2 there. But there is one more 2. So I cannot just stop here. I have to consider, what will I consider next? I have to consider multiples of 2 square also. So in multiples of 2 square, I can find 10 by 4 is equal to, again, 2 multiples of 4. And then I have multiples of 2 cube. There also I'll find some 2's. So it is 10 by 8. And I'll find how many 2's there? I find only 1 2 there. Or how many multiples of 8 are there? There is only one multiple of 8, and so 1 2 I can take from there, right? Do you understand this? I have listed out the multiples. Why have I listed out the multiples of powers of 2? Because in all those multiples I'll find the 2's. Whatever is left over here I can find here. Now whatever is left over here I can find here. Okay, whatever I have not found here I can find it here. You understand this? So finally, so how many do we get? Just add these. Okay. So when you have a question like this, find the largest power of a prime number in a factorial. What you have to do is you have to find the multiples of the powers of this prime number in this factorial and add up the number of multiples. You get the overall number of that particular prime number in the factorial. Okay. What is the final answer? It is 8. So did you understand? You have to find the multiples of 2, 2 square and 2 cube to get all the 2's here. Okay. Next, another question. Let's take a bigger question now this time. So again, I'm taking the prime number here. right? I'm taking the prime number here, and composite number we'll see. The next question will be that of a composite number. So we have to find the highest power of 3 in 95 factorial. So let us first look at our usual method, the one that we discussed in the last slide. Let us apply that here also. 95 is 95 factorial is 95 into 94, etc. till 1. Again, we have to find, our objective is to find all the 3's here. So first of all, I'll get them in multiples of 3. How many multiples of 3 are there in these 95 numbers? How many multiples of 3 are there? 95 by 3. So that is 31. Okay, next I have to find the multiples of 3 square. The next set of 3's I'll get there, 3 square. Sum of the 3's I'll get there. So 95 by 3 square or 95 by 9, I get 10. So I have 10 multiples of 9 in 95 numbers. Then 27. Next is, the next power is of 3 is 27. So multiples of 27 I get 4. And multiples of 81 again I get 1. Okay, so there I stop. Once we get 1, we can stop there because we cannot go any further. Okay, I cannot do 95 by 3 raised to 5, right? Because only 95 numbers are there. I cannot go beyond 95. So here I stop and I add up all this. 31 plus 10 plus 4 plus 1. Okay, 46. Now this method is fine, but still you can reduce the time by taking this denote. This is a way of denoting the same process here. I'll explain it to you. The process, what is the process? We are finding the multiples of the powers of 3 or 2 or whatever prime number we are supposed to find. So if we find that and add it, we get it. Now this can be simulated in a different way, or this can be denoted, that would be a better word, denoted in a different way. I am borrowing the factorization notation here, but actually we are not doing factorization here. We are just borrowing the notation so that we can apply this method in an easy way. So what do we do here? 95 is divided by 3. What is the quotient? It is 31. We are just taking the quotient. Remember, we are not trying to divide it. We just want the quotient. What is this quotient giving me? 31 is giving me the number of multiples of 3. That is my aim. That is all I want to find. Okay, I'm not trying to divide it. So 95 divided by 3 will give me 31. Why have I taken a 3 here? Because I have to find the highest power of 3. That's why I have divided it by 3. So I get 31. Further, you divide it by 3. Again, the quotient is what we have to take. So I get 10. Then again, you divide it by 3. I get 3. And finally, when I divide it by 3, I get 1. Now, what is the 31, 10, 3 and 1? That is what we found here, right? 31, 10. This is 3. Okay, this is not 4. This is 3. So the answer should be 45. Okay, this is a mistake. Okay, so here it is 31, right? 10, then 3, not 4. Okay, here I have written it as 4. That is not correct. It is 3. So 31, 10, 3 and 1 are the multiples, number of multiples of the powers of 3. So you just add them here and you get the answer as 45, not 46. Okay, so I hope you understood this method. This is not factorization, but just a way of denoting the multiples of the powers of whatever prime number we are supposed to find out. Okay, let's look at some examples so that it becomes clear to you. Okay. Now here we have a question. Highest power of 4 in 30 factorial. Okay, so highest power of 4 in 30 factorial means 4 is a composite number. So it is no longer a prime number. But we cannot do a composite number directly. The answer will not be correct. If you try to do it, do the method that I told you with 4, that will not give me the correct answer because 4 is a composite number. It will not give me all the multiples of 4. So I have to split 4 into its factors. What are the factors? 2 and 2. And now it has become prime, right? Prime factors. Divide it into prime factors. So I get 2. Okay. And I have to find the highest power of 2 in 30 factorial. So here, highest power of 2, how do we find? Again, that factorization, the way you denote factorization, the same method. 30 divided by 2. I need highest power of 2, so I divide it by 2. I get 15. 15 divided by 2, I get 7. 7 divided by 2, I get 3. 3 divided by 2, I get 1. Just add them up. 15 plus 7 plus 3 plus 1. Okay. So what do I get? I get 26 here. Okay, this is not the answer. This is only the highest power of 2. But I need the highest power of 2 square. So let us map this to 2 square. 2 raised to 26 can be written as 2 square raised to 13. Isn't it? 2 raised to 26 can be written as 2 square raised to 13. So what is the highest power of 2 square, or what is the highest power of 4? It is 13. So your answer is 13. Okay. The next one, highest power of 6, another composite number, but it's not a perfect square. So here, the 6 can be, if you prime factorize it, 6 is equal to 2 into 3. Okay. Whenever you are prime factorizing, when you're doing this question, your first step is to prime factorize if it is a composite number. Now, when you're prime factorizing, please take the two factors which are co-prime to each other. In the case of 6, these are the only two factors, 2 and 3, and they are co-prime. But if you're taking something like 12, if you're taking 12, don't take 2 and 6, because there is a common factor among 2 and 6. Take 4 and 3. Those are the co-prime factors. Okay. So here we have 6 is equal to 2 into 3. Right. Now what should I do? Should I take the highest power of 2 or highest power of 3? I must take the higher factor here and find the highest power of the higher factor in 100 factorial. Why? Because I get a 6 only if both 2 and 3 is there. Okay, and 2's will be definitely more than 3's. But it does not matter how many 2's are there. We get a 6 only if both 2 and 3 are there, isn't it? Therefore, we take the power of 3 and automatically we'll get the power of 6. So what you have to remember here is, when you get a composite number, your first step is to prime factorize it, divide it into prime factors. Okay, take the highest factor and find the highest power of that factor there, because the number of 6's will correspond to the number of the higher factors available there. Okay, so here your number of 6's will correspond to the number of 3's. How many 3's are there? That many 6's will be there. I hope you understood it. So let me find the highest power of 3 in 100 factorial. So 100 divided by 3 is 33. Again divided by 3 you get 11. Again divided by 3 you get 3. And then finally you have the 1. So we can stop there and add up the multiples. So we get the answer as 48. Okay, so this is how you will do a composite number. Now another way of asking this question would be, find the number of zeros at the end of 48 factorial. What is actually being asked here? Number of zeros means number of tens. You have to find all the tens, or you have to find the highest power of 10 in 48 factorial, right? So 10, first of all, what is your 10 is a composite number. So we have to prime factorize it. So we factorize it into 2 and 5, right? Which is the higher factor here? Higher factor is 5. So we find the highest power of 5 in 48, right? So here we get it as 48 when you divide by 5 you get 9. 9 again when you divide by 5 you get 1. So we can stop there. Total number of, or highest power of 10 in 48 factorial is 10. Okay. Okay, the question is hidden here. Find the maximum value of n such that 157 factorial is perfectly divisible. That is the word there. Perfectly divisible by 10 raised to n. The question is the same. You are required to find the highest power of 10 in 156 factorial. That is what it means. So here again 10 can be factorized into 2 and 5. Right? And then we can do it by 5. We can do the factorization by 5 and go on like that, right? So we get 31 plus 6 plus 1, which is equal to 38. I hope this is clear. So this is one kind of question, a very popular question which is often asked in different kinds of competitive examinations, the factorial question. Okay, so that's it for this video. Thank you.